For this week's project, we chose option 2, so we are going to explain to you some of the changes we made to the code of Scratch. We added 2 features. The first one is a kit version of the simulation, but we'll talk about that later. First, we'll talk about the classic model and the other new feature, masks. If you click on the classic simulation, you get a screen where you have 6 seconds to change the values of the variables. The values are expressed in percentages, and they are the percentage of people who stay at home and the percentage of people that wear masks. After changing these values to your taste, the simulation will start. Here you can see 5 types of dots. The dark blue ones which haven't contracted the virus and don't wear a mask. The light blue ones which haven't contracted the virus but do wear a mask. The pink ones which have contracted the virus and don't wear a mask. The purple ones which are infected but wear masks. And finally, the green ones. We have created antibodies against the virus after getting infected. The people that stay at home are represented by the dots that don't move. Another new characteristic is the probability of getting infected depending on if the infected or healthy people wear masks. There's also a graph which represents the number of infected people.
To see how this works, let's make an example. In this example, we have to imagine a village where few people can stay at home, but most of them are responsible enough to wear masks. So we set the variables in 30% of people stay at home and 85% of people wear masks. Let's see how this goes. As we can see, in this case, the spread of the virus is very slower, and it has disappeared very faster. But as I said, in this case, because we've tried other in the same percentage other times, and sometimes the spread of the virus was slower, other time faster, but always in a slow rate thanks to the use of masks. Now let's talk about the version of the kids. We created this model thinking about the kids in the school and even in the kindergarten to explain them how serious the spreading of the virus is in an easy and enjoyable way. It's because of this that the first screen explains the variables. In the second screen, the color of the dots and the possibilities of getting infected are also explained. For example, a healthy person that doesn't wear a mask can be infected by a sick person that also doesn't wear a mask in a 98% of possibilities. We developed the variable of the mask because it was a measure that was very important in the management of the virus in Spain, and we wanted to represent it. This was our work, and we hope you like it.